Access Minnesota. Issues that matter to you. Access Minnesota brings you the newsmakers and the stories that shape our everyday lives, with analysis from University of Minnesota faculty experts. Now, here's Jim Dubois.
This summer on June 21st, a powerful storm knocked out power to approximately 610,000 residents in the metro area and parts of central Minnesota. It was the largest power outage in state history, leaving some neighborhoods in the dark for several days. Xcel Energy called in crews from 14 states to help restore service. This month on Access Minnesota, we sit down with Dr. Massoud Amin, an expert on smart grid technology. We'll learn how a so-called self-healing grid could benefit communities after large storms like the one we just experienced, and how Minnesota and the nation can update our energy infrastructure. But first, weather expert Kenny Blumenfeld talks about the unique characteristics of this storm and why so many trees were felled around the metro area. Kenny Blumenfeld is an adjunct professor of geography at the University of Minnesota. He's also on the community faculty of Metro State University. Kenny, welcome back to Access Minnesota.
It's great to be back, Jim.
On June 21st of this summer, Kenny, a major thunderstorm roared through the Twin Cities area, actually impacting parts of central Minnesota. Here in the Twin Cities, about 600,000 customers of Xcel Energy lost power, some for several days at a time, and many, many trees were felled. Tell us about the weather conditions that made this storm so potent.
Well, I think there's a few different factors that made the storms as severe as they were, or at least as apparently severe. One was the weather conditions themselves. The winds aloft were fairly strong, and there was a big pool of warm and moist air, which is the energy source for most thunderstorms. And as the thunderstorms grew, they were able to tap into some of those strong winds aloft and then sort of channel them down, and that's a good ingredient or good recipe for some sort of wind damage. A non-meteorological factor was that the ground had been softened up from storms the night before. So the night before those storms came in, there had been another almost maybe equally potent line of storms that moved through the Twin Cities, knocked down some trees, but also put 2 to 4 inches of rainfall down. And that softened up the soil, and that made the trees more susceptible to at least being uprooted. Now, where we saw the trees being snapped or having some of the big limbs sort of snapped off, had nothing to do with being uprooted, that would be a sign of just a very strong winds. It was a large area where the winds aloft were pretty strong. They were coming over the top of a high pressure ridge. And that was just, it's a really good recipe for sort of long-lasting storms that can feed off of the warm, moist air and also channel the high-energy winds aloft.
While the damage was generally pretty widespread, you could look around, though, and see pockets of more intense damage in certain areas. Why were some areas more heavily damaged and other areas spared the destruction?
That's a fantastic question. And in a way, we don't have enough of the meteorological data to know for sure. We know that storms are going to be locally more intense, and the downburst winds might be a bit stronger in some areas. But then there's going to be a feedback between, say, the topography, where you have hills, where you have open areas, and then the storm itself. And then you also have, some trees maybe were in areas that were more saturated, where the ground was more saturated or wetter than in other areas. And so that's going to make them more susceptible to being uprooted. So you have potential meteorological factors that are almost on a scale too fine for us to resolve. I mean, we could go back and look at some of the radar data, but really there's a good chance that it's other sort of non-meteorological factors. For example, we're by a lake here, and when the winds come across that lake, they have this open expanse where they can really accelerate for, half mile or a mile. Frequently they'll get to the other side and they'll be stronger on the other side than they were on the side that they originated. So kind of the leeward versus the windward side of the lake, because they've had that ability to accelerate a bit. We see this in the plains. We see this wherever you have sort of a flat expanse. So often one side of a ball field gets more damage than the other side for that same reason. So there's all these factors that could have been influencing the damage pattern. And a lot of them I'd have to believe, are not meteorological at all. They have to do with the way that the landscape is sort of shaped and how different things on the land are distributed.
The Minneapolis City Council noted that this most recent storm actually caused more damage and felled more trees than the North Minneapolis tornado in 2011. Why was this storm so much more destructive than some of the recent tornadoes in the metro area?
I think we have to be careful with that kind of interpretation or with that conclusion, because a tornado, I mean, the tornado was relatively narrow, at most a half a mile wide, I think, at its widest, and it spent most of its life in the 1 to 200 yards wide neighborhood. And even though it had a 15-mile long track or 12-mile long track, it's hard to compare that with one of these bow echoes, where the potential for wind damage is 5 to 7 miles long within a storm that's then moving forward and is covering, in this case, it covered, a couple hundred miles coming out of South Dakota. So mathematically, you've just got a better potential for total tree devastation when you have a larger area that's being affected by the winds. But if you look at a sort of a damage density standpoint, that damage per unit area, damage per square mile, far more trees came down from the tornado in North Minneapolis and some of the suburbs in May of 2011 on a, again, per unit area basis. So this kind of storm had in its favor that it's just going to cover a lot more ground than, say, a tornado. But the winds in this storm weren't as strong as the tornado winds, so you'd see less concentration of damage and sort of a wider distribution of it.
With the loss of so many trees, what sort of impact will that have on the environment?
In a lot of ways, we can't know. The total tree mortality was large relative to what we're used to experiencing. But if you look on the landscape after all the cleanup, it's actually fairly hard to detect, because a lot of this was single trees. Some blocks you lost 1 out of 150 trees. And I think another thing to consider is that our climate is changing, and this is affecting vegetation. And it's not clear how resilient the trees that currently reside here are going to be to the new climatic regime. And if they're probably not going to make it all the way through our climate change. And we don't know when that replacement is really going to occur. But what's going to happen, is the trees are going to be more susceptible to disease, to all kinds of agents of mortality. And that includes windstorms. So I think that there's a lot going on. Again, some of it's meteorological, and some of it's climatic, and some of it has nothing to do with either, and is just about the ecology, and then some of it is the sort of interface between all of these things because we have a changing climate. I think additionally, this is a urban area, and it can feel like a forest, but it's not really a forested landscape, and this really wasn't a blowdown. So the ecological implications are not the same as what we had in the Boundary Waters in 1999, where you had a huge swath of forest completely removed. I think one of the things that is difficult for us to comprehend is that we're really susceptible to, we really feel the kind of ecological impact because we live among the trees. So the trees come down on our houses and on our cars, and they cross our streets and they disrupt traffic. So the impact on society is actually probably more significant than the total ecological impact of this kind of a wind event.
If we're talking about more intense, more severe storms becoming the new norm, do we need to look at ways to make structures more resistant to high winds?
I would be making the investments in the infrastructure. One of the things that we learned is that our grid is pretty susceptible. The power lines are obviously quite vulnerable. Trees coming down on them, in general, just the disruption. So much of it had to do with losing, 600,000 customers losing power. So I would be looking more at the infrastructure and then also the roads, because I think one of the things we're probably most confident about. I'm pretty sure that we're going to have somewhat scientifically higher frequency of straight line wind events, and probably the same for tornadoes, but a much more conventionally noticeable increase in extreme rainfall. So I would be making the investments in the infrastructure that's built to tolerate that. Now, I'm not talking about tearing up all the streets, but when we get to the next generation of roads, the next generation of culverts and whatnot, keeping in mind that not only are the new values for extreme rainfall, the 100-year rainfalls, bigger than they used to be, but also they're still increasing too. So to keep those values flexible with time and build in the fact that it's going to be getting wetter with a higher frequency, I think that's going to be that's where I would put my money if I were investing. As far as structures, you can always, I think you can consult with the landscape architects and come up with sort of the best design without making structural changes. But if you're talking about making structural changes that are preparing you for a, more 50 and 60 mile an hour winds, I'm not sure if that's the way to put the money.
Kenny Blumenfeld is an adjunct professor of geography at the University of Minnesota and on the community faculty at Metro State University. Kenny, thanks so much for joining us on Access Minnesota.
It's a pleasure, Jim.
When Access Minnesota returns, we'll ask Massoud Amin, professor of electrical and computer engineering at the University of Minnesota, whether smart grid technology would have helped keep the power on after June's powerful storm.
Access Minnesota will return after these messages.